Hi, I'm Chungha, and in this talk, I'm going to present the how we automatically refine permissions of IAM policy in AWS. So in AWS, customers deal with access controls with various types of resources and services. Especially, this access control is about who has access to what resources. So to support this access control, AWS customers use AWS IAM policy. AWS Cloud's access controls is determined by IAM policy, and this policy language provides the fine-grained access controls. So when writing these IAM policies, it is important to give least privilege. And least privilege means you need to grant only required permissions to perform a task. So in AWS, there are security best practices emphasizing that least privilege is important and some ways to achieve it. Usually what AWS user does is they write the broad permissions when writing IAM policies, since they don't have exact information of required permissions at the beginning. And then they achieve the least privilege by removing unnecessary permissions by updating the IAM policies they wrote. But manual policy update is not trivial because it requires the understanding of necessary or unnecessary permissions. So to help this direction, we present this IAM policy refiner. IAM policy refiner helps to modify policies to remove permissions automatically. And it takes the user IAM policy to refine. And it takes another input, which is access data for a certain period of time. And this access data is useful for refinement because it gives an indication of what permissions are actually required. And our technique has been applied to a production setting of AWS IAM Access Analyzer to recommend IAM policies based on unused permissions. And for this service, IAM policy is applied with a very specific setting, but in this talk, I'm going to talk about the general approach of IAM policy refiner. So I mentioned IAM policy refiner takes the IAM policy input as an input with access data and refine it. But we haven't answered this question. What is the right way of refining policy? So let me use a visualization to better understand it. Here, the orange circle shows all possible requests allowed by the input policy, and this green area shows the actual access data. And our goal is to find out the right level of refined policy. Basically, our journey is about finding the simplest refinement from the input policy and achieving the right level of refinement. So for that, we defined 3 properties that should be satisfied by a refined policy. They are readability, soundness, and tightness. So in this talk, I'll use very simple example without any formal notations to describe these, but we actually formally define this in our paper, so please check out our paper if you're interested. And in our setting, basically, this right level of refinement is the least permissive policy that is readable and sound. So let's explore these properties with an IAM policy example. And here is a simplified structure of IAM policy, and I kept only details required to understand our technique. So policy consists of multiple statements, and each statement defines various elements such as effect, action, resource, IP address, or other types of elements. And each element uses the patterns to match values from requests. So let's take a look what this statement does. First, effect defines whether the statement is about allowing requests or denying requests. It says allow. So it is about this statement is about allowing requests. And this action element has these 2 string patterns, encrypt and decrypt, meaning the action value for the request should be either encrypt or decrypt to be allowed. And this resource element uses my key dash star. And the star here means in IAM policy is a wildcard for any length of any character. So that means the resource value from request should start with my key dash. And the here last one is the IP address that specifies the specific range of the IP address, meaning the request should come from this range. So this means all elements of request values should be matched with these patterns in this statement in a conjunctive way to be allowed. Since we understand the basic concept of IAM policy, let's think about a possible simple refinement based on access data. And this left side shows the input policy I showed. And now we have this access data. This access data consists of 2 requests. And one thing we can think of in terms of refinement is we can refine the policy to match exactly on the access data. So this refined policy has 2 statements, and each statement is the one-on-one exact match for the request. First request to the first statement and second to second. For example, the first statement exactly matches the value of the resource from the first request by having my_111 instead of my_star. And similar thing happens to the second statement by having my_222. And also, it added one more element named account ID, and that is coming from access data. So it looks like this refined policy allows the exact request from access data, and it is kind of refined version from the input policy. But this kind of approach, when we use this kind of approach, what is the problem? The refined policy is structurally different from the input policy, making it unreadable. If we give this policy to authors of the input policy, they are not able to understand what's changed from the input policy. And another problem of this kind of structure change is it might lead to overfitting policy to access data. So this policy might miss future access requests if the access data is not complete. So for that, we define the property named the readability. This property says the refined policy should not add a new statement, and no element should be added to these statements. For example, account ID from the previous example shouldn't be added. So with the same input policy and the access data, now we have this refined policy structure. This refined policy would keep the statement without adding new statements. And it will have the same set of elements. In this example, we have this ... on the patterns of refined policy since we haven't discussed how to achieve these patterns yet. So basically, this readability keeps the syntactical structure of the input policy by avoiding the overfitting issues. And this property limits the policy refinement in a specific way since we only need to refine the existing element patterns. So let's talk about how to achieve this readable refined policy. Intuition of getting readable refined policies, we interpret each element pattern as a predicate. And because of the IAM policy semantics, if we have more restrict predicate for each element, the statement will match less number of requests. And this results in matching less number of requests for policy. So basically, we reduce the problem of refining policies into refining statements, and these refining statements can be reduced to the problem of refining predicates. So our goal is to find sound and tight predicates, and this would result in achieving the right level of refined policy. And let's look at what these sound and tight predicates are. Sound predicate means the predicate should be less permissive than original predicate, and it should allow all the requests. This is the same policy and access data I have showed. And since the requests are already allowed by the input policy here, we refine predicate with the exact matched request values. So we have this my_star in the input policy, and we have values from request my_111 and my_222 from resource element. So basically, we use these values to refine my_star to this by having this refined policy. And this predicate should allow all matched values, which are my_111 and 222. So in this way, we achieve the sound predicate. To better understand, let's assume we have more statements and more longer requests. In a similar way, we can map the statements to the matched request so that we can refine each predicate with the matched values from the matched request. So let's talk about tight predicate. The tightness defines the least permissive predicate among sound predicates. And this is very useful property in, when finding the least permissive policy, since that's our goal in the refinement. And from the same example, there are you can think of many possible predicates for this resource element that are sound. For example, we can choose my key dash question mark question mark question mark. And question mark in IAM policy is a wildcard for single length of any character. Another candidate can be my key dash question mark star. And also we can keep the same predicate from the input policy, which is my key dash star. So what is the least permissive predicate and how do we find this? So we understand this problem as a lattice problem. First, we have this top and bottom, where this top is the most general predicate from the input policy, and which is my key dash, and bottom is nothing's matched. Then we have these two request values, my key dash 111 and my key dash 222. We can interpret these values as a predicate too. And we can keep constructing these lattice with the possible predicates, such as my key dash question mark or my key dash question mark star. So when the value is closer to the bottom, it is more restrict pattern. And we can use partial order to find the least permissive predicate. So this is intuitive. Basically, we find the my key dash question mark is the lowest point in this lattice, and that is above both my key dash 111 and my key dash 222, meaning it allows both of these. So basically, this is the join operation of lattice of two values. So our solution is we can define appropriate lattice with join operation for all possible element predicates in this IAM policy. For example, we provide the join operation for equal, not equal, numeric comparison, regex with wildcards, and IP masks. Then we can find the least permissive predicates, and that helps to us find least permissive and sound policy. And to achieve this lattice-based approach, we designed this join operation to be associative and commutative. It means the order doesn't matter applying these join operations. So we can actually parallelize this approach when there are a lot of requests. So here's the recap of IAM policy refiner's technique. So we define these three properties: readability, soundness, and tightness. And we define the right level of refined policy. And we reduce the problem of this refining policy into smaller problem, which is refining predicates. Let's switch our gear to the evaluation section. We evaluated this IAM policy refiner with 3 months of access data from AWS CloudShell logs for AWS IAM roles. And each IAM role can have multiple policies attached, so we refine these policies with this access data. We chose these 3 months of data because it gives enough behavioral applications, and we can understand the indication of required permissions. And we conducted various research questions in our paper, but let's focus on these 3 in this talk. First, IAM policy should reduce the permissions effectively, and it should be parallelizable. Also, the refined policy should avoid overfitting. And here's the experimental table. The first column shows the name of the IAM roles, and the second column shows the number of requests to refine the policies attached to each role. Let's look at the number of actions columns. They show the number of actions allowed before and after refinement. On average, around 77% of actions are actually removed. For example, there was a drastic case, reduction from 726 actions allowed, now is 20 actions. And number of resource columns show how many resources values are actually refined. On average, we found 88% of resource values are actually removed or refined. And the time columns shows the execution time between running this with 1 CPU versus 96 virtual CPUs. And we saw 8.7 times improvement on this parallelization. And this particular case shows it took around 75 seconds to complete the job. Now it takes around 5 seconds with parallelization. And to check the overfitting, we split the 3 months of access data into training set and test set. We use the training set to refine the policies, and we use the remained access data to test how much of them are actually allowed by this refined policy. And here it shows we use first 10% of the access data for refining policies, and 90% of data were to check if the refined policy can allow them. And by increasing the test data, we check when the refined policy can allow all the remaining access data, such as 20% of refining policy and 80% for checking refined policy. So based on our results, we saw 50% of requests were enough to avoid overfitting, and refined policy, which is around 2 months of data. Here's the conclusion. We presented it. IAM policy finder that automatically refines IAM policies with access data, and we define this right level of refinement with the readability, soundness, and property, these 3 properties. And by reducing the problem of refining policies into refining predicates, we could tackle this smaller problem with these predicates. And we checked the effectiveness of approach on real-world AWS access data. As a highlight, specific setting of IAM policy finder has been applied to a production setting. And our paper explains these settings. So please check out our paper. Thanks for listening to this, and please reach out to me or our team members if you have any questions on this service or work. Thanks.
Questions?
Right. So I was wondering if, because the lattice that you show it was carefully designed. Like the more you go up, the less information you have, right? But does it happen in practice? Like when you need to enumerate the resources example, you're now with a very long list of. If you go back to the slide where you say resource.
Here?
Yeah. So. Can it happen that in the resource you just put like one element in resource? It's like with the question mark, or a star, or a specific thing. Can it happen that there are cases where you need to put a list of resources, or that doesn't happen in your approach?
Oh, right. So IAM policy syntax allows this list of resources with each of them can be regex, and same thing can be applied. We can actually map the match request to the corresponding target resource patterns, the predicate, and then we refine each of them.
Because I'm thinking like, you want readability, right? So if you have a list of resources, you don't want a list of 2,000 resources. You want to perhaps generalize the resources so that the list gets smaller in terms of readability.
Right, but in terms of like refinement here, we don't change the number of resource patterns that exist in the input policy, and we keep the number of.
Okay, you keep the you keep the.
Yeah,
number.
but you have a good point on the having this enumerating list or refining those. Those can be defined by the readability property.
Because that will give you, because here you always go up in the lattice, but if you have this kind of constraints, you might go up and down, depends on readability. That's
yeah,
kind
right.
Of
the customization can be applied here by how we design this lattice-based approach.
Okay, cool.
Yeah.
Thanks.
Thanks for the good question.
Thanks for the talk. Does the policy refiner support refining principles? For example, if you have an EKS node group in the policy, but only one node is ever used to use that policy.
Okay, that is a very good question with the knowledge of AWS. Yeah, current approach doesn't support the principle. And okay. That's kind of future work because the principle doesn't work in the same way as a resource or actions by having these regex because the format patterns of the principles can change based on the roles or users or groups. So yeah, so that's kind of approach we are looking at right now.
Cool,
yeah.
Thank you.
All right, let's thank Chungha again.